Right. So our objective in lecture 6 would be to finally use a simscape block for the whatever type of motor that we are using. Instead of modeling the effect of the motor or modeling the torque of the motor using a combination of simscape blocks. Sorry, simulink blocks. So this is what we obtained in lecture 5. And if you remember, this section models the torque of the permanent magnet brushed DC motor that we are using based on the current angular velocity of the motor. Takes the angular velocity as an input and outputs the torque value. So we will be dropping in a simscape block for the PMB DC motor and replacing this. Now there are quite some advantages in using a simscape block for the whole motor instead of modeling effects one by one using simulink blocks. And the foremost of those advantages is that the simscape block for a model is very comprehensive, and to the electric in addition to the torque generated by the motor, all electromagnetic, mechanical, and thermal effects are included in this within this block itself. And you may read about these advantages on your own. Right. So including all these effects into our system model can be done easily by dragging and dropping this mm, simscape block that you see on the slide. However, when we drag and drop this block, what MathWorks knows is what type of motor that we are using. It does not know the exact characteristics of the motor that we plan to use. So in order for us to specify what these parameters or characteristics of that motor are, we need to uh, specify a list of characteristics of the that motor type we are using in a dialog box which pops up upon double clicking this simscape block. And this is the list of such parameters, and there are multiple approaches that we can use to list these parameters. And if we use one such parameter, then we won't be needing to list all of these, but just a certain subset of this list. For example, if I am using the first approach of specifying the characteristics of the motor using the equivalent circuit parameters, then I would need to specify only the armature resistance, torque constant, and all these values which are in white color font. Once again, armature inductance, rotor inertia, and rotor damping. Instead of the first approach, if I am to use approach number 3, which is specifying the characteristics of the motor by weighted load and speed, then I would only need to specify this set of parameters. And if I am using the second approach, which is specifying the characteristics of the motor by stall torque and no load speed, then these are the characteristics I need to specify in addition to this white color font characteristics. Now what we did in lectures 3 to 5 is somewhat specification of the motor characteristics using stall torque and no load speed. If you remember what we did, we had from the datasheet we obtained a curve for the relationship between torque of the motor and angular speed of the motor. And if you can remember that particular curve, the y-intercept was the torque at no load, sorry, the torque at no the torque at zero speed, which is also called the stall torque, and the x intercept was the maximum speed that the motor could reach, and also uh, that speed was achieved at no 0 newton meters of torque, which is also, therefore it is also called the no load speed. So those were the x and y intercepts, and from the x and y intercepts we obtained an expression for the curve in y equals mx plus c format, and we implemented that using Simulink blocks. So when we specify, if we use approach 2 and we specify the stall torque and the no load speed, that is what MATLAB would be doing with regards to the relationship between torque and speed. But what MathWorks does internally within these blocks is not quite visible to us. Only the effects would be visible in terms of outputs. Right. So that's with regards to specifying the characteristics of the motor for when we are using a simscape block for the PMBDC motor. And mind you that this set of parameters only for PMBDC motors. For other types of motors, we have different lists of characteristic parameters. And one further note, you don't need to keep in mind what these required parameters are. You will see later on that when you double click on the SimScape block, a dialog box will pop up, and but first you need to select which approach that you will be following, and upon selecting that approach, then MATLAB will prompt the required characteristics one by one. Right? So this would be more clearer if we do an activity, and